So when you graph a piecewise function, it's like graphing three equations in one. So the first equation that we're going to graph is this one. So this is saying whenever it's left, because it's less than, so that's the left of -1. What I always tell my students is plug in that endpoint, the -1, into that equation first. So I'm going to put -1 into my equation, and I will get -3 out. So this is the point I'm going to graph first, and that point will be an open circle. So left 1, down 3, open circle right here. So my circle looks funny, but now I'm going to evaluate a point to the left of that, and I'm not sure, maybe your teacher wants so many points, so a point to the left of that would be -2, so if I plug -2, because that's to the left of -1, that would give me 0. So this is -2, 0, that's going to be -2, 0, is a solid point, because that's to the left, and it keeps going up. I'm not sure what your teacher, how many points they want, but a x squared should be a u, kind of like, so it's half of the u. So if I look at this one, this is just where y is 1. So if I look for where y is 1, it's right here. This is where y is 1. It's saying or equal to, so it's going to be a solid dot, so in between these 2 points. So if I graph that, -1, 1, it's a solid point. The reason why I picked -1 is because of this end point right here. And then it will be 1, 1. So each time y is 1, that's what that's saying. And then it will change your x values based on those parameters. So then 1, 1. And that's a straight line. So that's a number 1. And my last one is another x squared. So I'm going to evaluate at 1. So if I plug 1 into my equation, I'm going to get 2 out. So this is 1, 2. Again, when I look at this, there's no line, so it's going to be an open circle when I plot that point. So 1, 2, open circle. That's my best open circle I got. So then next point to the right, because it's saying x is greater, so anything greater than that, I'm going to put 2 into my equation, and I get 5 out. So depending on your teacher, it might be different when you're putting points, or you want to figure out how many points you actually need. And then here's it. So this is not the best because my open circles are funky, but that's kind of what it looks like for each graph. So you have to graph each one separately. It's always based on your endpoints, these points right here. So next question. So one thing right away when I'm noticing this is just x equals 2. There's 1 point here. There's just going to be 1 point there. This is going to be the only one that's a solid line because it's equal to. So I'm going to plot that point right away. This one's in the middle. So this is saying x is 2, y is 5. So at 2, positive 5, that's just one solid circle. This one, so I'm going to evaluate x at 2 first. I'm going to plug 2 into my equation. And if I plug 2 in my equation, I get 3 out. So at this point, 2, 3, that's going to be an open circle. So at positive 2, positive 3, that's an open circle. Again, sorry about my circles. Doesn't look that great, but now I'm going to plug in a number that would be less than 2. So I'm going to pick 1. So 1 plus 1 equals 2. So this is my other point. So positive 1, positive 2. And this is saying it keeps on going, and all the numbers less than. So this would be a straight line this way. And my last one here, I'm going to plug 2 into my equation. So I have 2 minus 2 squared, so that would give me 0. So at 2, 0, again, it's going to be an open circle. So positive 2, 0, open circle here. And now I'm going to evaluate number on the right, so I'm going to plug 3 into my equation. If I plug 3 in, I get 1 out. So positive 3, positive 1. And again, this is a u, so it might be helpful to plug more than 1 point in, because I know it's a u because it's squared. So if I plug 4 into my equation, 4 minus 2 is 2, 2 squared is 4, 4, 4. And it looks like this. And my open circles are not that great. But when you're looking at these, it's always saying, okay, this is what x, or this is what y would be if x was 0. When I'm looking right here, wherever the closed circle is, that's telling you what y would be if x is 2. Okay, and before going into the second, the last question when you're finding, I'm just gonna go over to the standard form of x squared, so that you know that key thing when we're writing the equation for anything with x squared, we have to know what the vertex is, and we have to know the pattern between points. So from the vertex to the next point, it's a rise of 1 over 2, 1 over 1, like that. And then from that point, then we rise up 3 over 1 on both sides, 3 over 1. So it's important to know what points we're dealing with before we can actually write the equation, because then we rise up 5 over 1. So this one's up 5, this one's up 3, this one's up 1, because we have to know what the pattern is before we can actually look at what the equation is. So I'm looking right here, it looks like both the first and last equation, so this one right here and this one right here, look to me like a quadratic. So one thing that I'm going to do, first thing, I know my endpoints would be at a -1 and a 1, because that's where the graph changes. So I'm writing my equation, and I'm first looking at this. So here's a point on this graph, here's a point to graph. This was a rise of 3. This is a difference of 3. So I know then to find my vertex, it would be a 1. So this right here is my vertex. I'm going to be using that for my first equation. So this vertex would be 0, 3. So in writing your equation, the other thing that I notice is that it's flipped. It's pointing down instead of pointing up. So my equation would be, well, actually not in parentheses, because I didn't move left or right, it'd just be x squared. And I moved up 3. That's using my vertex right there. So that's my equation. However, I also have a negative. I have a negative in front because it was a flip. Because it's flipped upside down, then my a is negative. So that's my equation. And then when I'm writing out my restrictions, this equation, again, if I look here, started at -1, and so everything to the left. So I'm writing this out. X is less than -1. Because it's everything to the left of that. That's my first equation. Second equation is going to be this point right here. And I notice here it's a solid dot and an open dot. So I'm going to write out my parameters first. Sometimes it's easier because it's going to be -1. So that's where I'm starting at. That's where my x is right here. That's where I get that -1. And then it would be less than or equal to, because that was a solid dot, my x, which is less than +1. And the reason I have a +1 is because it stops right there. And now I'm looking at my equation. So first, this looks like a straight line. And so here's my b, my y-intercept. It's a rise over run. So my rise over run is just 1. So my equation for this is just going to be x. Because my b is 0, and my equation is rise over run would be just x. And then my last one, I'm starting at 1, because that's where x is 1. There's going to be a line here, because this is a solid dot. And again, it looks like this is going to be a curve. So first I'm going to look at this. Here's a point. This was a difference of 3 in between those 2 points. So to find my vertex, it'd be this point right here. So my vertex for that blue equation didn't move left or right, and I moved down 1. That equation, I didn't move left or right, so it would just be x squared. If I moved left or right, that would be in parentheses something, x plus or minus something 1. And then I moved down 1, so this would be my down 1. And it's a positive that's pointing up, so there's no negative in front. And my restriction would be my x, it's greater than or equal to, because it was a solid 1. And that's my piecewise function for that. So it's these 3 equations together is that graph. Hopefully that helps. Let me know if you need more help.